In this video, we're going to use node voltage in order to find the voltages here, V1, V2, and V3. Now you'll notice that in this circuit, ground has already been designated as the bottom node here, and we can go ahead and call that ground. We have 0 here, we have our V1, V2, V3 labeled already. We do have one issue here, is that we have these sources that are voltage sources that are in between nodes. So we're going to have to combine everything together here into one giant supernode. And so at this point in time, if that's the supernode, we're looking at everything coming out of it. We're going to have these different currents here. However, if you notice something, this current going up and this current over here going up, they're really the same current in opposite directions. And so those are going to end up canceling out. So one thing with supernodes is if you have a resistor that is in parallel with the supernode, then what you can in fact do is you can just include that in your supernode and really just have to look at the currents leaving the supernode. Now it's just going to be these three currents here. So that's a little bit of an advanced technique, but you would see if you actually wrote out the equations that those two terms would cancel out. So let's see, as is written, the one on the left going down is going to be V1 minus 0 over 2. And the middle going down would be V2 minus 0 over 4. And the one on the right going down would be V3 minus 0 over 3. Add up those currents, you're going to get 0. Then, whenever you have a supernode, you need to relate the different endpoints of the supernode. So in this case here, it looks like V1 is a 10 volt gain over V2. So V1 is you go V2 and add 10. And then for V3 over there, it's a 5 volt gain over V2. So V2 plus, not 5, 5i. And then you're going to need an equation relating your dependent variable I here, which is this left current. So that means I is going to be V1 minus 0 over 2. So right there would be a perfectly good system. No problems at all with that. You could solve that. The only thing is it's 4 variables and 4 equations. So it's a bit of work here. However, this would be perfectly fine. You could just work out the details. With that said though, I am not going to solve it this way. I'm going to show you a better way of doing this problem that may not be obvious. So when we're doing node voltage, you go ahead and you pick your node to be ground, you do everything here, and you might say, well, I don't get to pick my node because it already labeled something as ground. But remember that all voltage is relative. So as long as we understand that, we really can pick any node to be ground, even if it's not the one that is physically ground. And if I choose this middle node here, if I choose that to be ground, because I have 2 voltage sources connected directly to it, I'd have a 10 volt gain, so that means this over here would become 10. And I have a 5i gain, so this voltage here would become 5i. And then I would have only one variable, this voltage on the bottom, which is not 0, because it's not ground anymore. We'll just call that V. And so what we're going to do is we're going to just go do our node voltage equation at the node V. We only need one of them here. So we'd have V minus 10 over 2 plus V minus 0 over 4 plus V minus 5i over 3 is 0. I do need to get my dependent source equation. So my variable there is I, and in this case it's going to be 10 minus V over 2. So now I only have 2 equations and 2 variables to solve. It's going to be significantly easier. Maybe I'll go ahead and multiply everything in the top equation by 12. That would get me 6V minus 60 plus 3V plus 4V minus 20I is 0. And the bottom one, I'd have 2I is 10 minus V. So maybe solve for that V is going to be 10 minus 2I. Plug that in the top one here. 6 times 10 minus 2I minus 60 plus 3 times 10 minus 2i. Maybe I'll just combine things first, actually. So it was 6, 9. That looks like it's going to be 13v minus 20i is 60. That'll be easier to plug in my v now. 13 times 10 minus 2i plus minus 20i equals 60. That's going to be 130 minus 26i minus 20i is 60. And that's going to give me minus 46i is, what do we have here? Negative 70. So my I then is going to be 70 over 46. Divide top and bottom by 2. It's going to be 35 over 23 amps. So we have this answer here for our I. But if you look at the original problem, we want to know what V1, V2, and V3 are, not actually I. And you might say, well, I already know my V1 is 10 and my V3 is 5i, but that's actually not quite true. Because this thing is 10 here with reference to this being ground. And that is not actually what ground is in the real circuit. What we really want to know for V1, it's the voltage of this node with respect to the original ground. So really, V1 would be the difference between the 10 volts on top and the V on the bottom there. So we need to find our V here. V is 10 minus 2i. So 10 minus 2 times 35, 23. Let's see here. 230 minus 70 is going to be 160 over 23 volts for V. And my V1 then would be 10 minus that. So 10 minus 160 over 23. That's going to be 70 over 23 is my V1. If I want my V2, that would be 0 minus V. So that's going to be just a negative 160 over 23 volts. And my V3 would be 5i minus V. So 5 times I minus V, 160 over 23. And see, that's going to be 150, 175. It's going to be 15 over 23 volts. So the thing is, even if they have a ground selected at one location, you can actually move it into a different part of the circuit as long as you realize your final answer is what voltage you're trying to find with respect to which actual ground.